So I wanted to give you an opportunity to do so. All right, so looking at this, I want to do a couple of these questions with you. Notice that the answers are on the bottom of the page. So about halfway through class, when I give you time to work, this will be the first one I ask you to go back and do. But for now, let's just talk about one of each of the question types. So let's go ahead and do number 2 together. Anytime you do this type of limit question, what was the step that you always had to try first?
Plugging it in.
Okay. Just plug it in, or direct substitution, whatever you want to call it. You end up with the square root of 16, which is 4. A couple of these questions can be that easy. Direct substitution first, always, always, always. But then, like a question like number 7, again, you're welcome to just copy these down as examples. You'll have a few to practice yourself. Then in example 7, we try something like direct substitution, and the numerator goes to 0, which isn't necessarily a problem. The denominator goes to 0, which is not necessarily a problem, but if it's 0 over 0, it is a problem. Yeah?
On 2 of the answers, square root of 10.
Oh. Be careful with your arithmetic. 2 times 3 is 6. I must have done it twice or something. I don't know. So square root of 10. Thank you. I even had the answers down on the bottom, and I just didn't even check it. So, okay, so number 7 is a little different. We plug it in, we get 0 over 0. We know this 0 over 0 is an important calculus thing. It's the first major new math problem that we are trying to tackle in calculus. So the first time we looked at this, and you should have practiced a bunch of these already on one of the worksheets, the most common way to deal with this was factoring. So if the numerator and or the denominator factors, you should try that. Hope that something cancels, and if something cancels, then you should be able to plug it in and finish it up. So does that mean that the answer to this is -4?
No.
How come? That's all I got left. Good. It's in the denominator. So if your whole numerator cancels out, that still leaves behind a 1. 2 over 4 doesn't become 0 over 2. It becomes 1 over 2. So these cancel, you plug in -1, you end up with -1/4. So 0 over 0, first thing you should try is factoring, because factoring is one of the easier algebra processes, and it's the most commonly used one. Okay, so 2 more that we will look at together. Let's go back to
7. How did that get to -4? Because the parentheses things looks like it's x minus 2.
It's a 3.
Oh, it's a 3?
Yeah, it's a 3. Okay, so direct substitution, factor, cancel, direct substitution. Okay, back to question 1. Again, I'm just doing one of each to give you some reminders here. So, same thought process should be occurring. I know I got to do direct substitution. I hope I don't get 0 over 0. Question 1, we do get 0 over 0. I know to try factoring because it's the most common. This one doesn't factor. So, what was one of the other math tricks that we figured out or practiced to deal with a question like this?
Conjugate.
Okay. Do I want to multiply by the conjugate of the numerator or the denominator?
Denominator,
And how do you know that?
because it has the square root.
Good. Whichever one has the square root, you want his conjugate. Remember, conjugate just means the exact same thing, but change the middle sign. You need to put the same thing over itself, so it's like you're multiplying by 1. Okay, then we had to multiply these fractions together. So numerator times numerator. I guess you can FOIL that, but you're going to have to undo it if you do that. Denominator times denominator is going to give you your denominator, but the reason we picked conjugates is multiplying something by its conjugate always cancels out nicely. You get first times first. Outer would be the square root of x, but then inner would be minus the square root of x, so those are going to cancel anyway, and then a plus 1 minus 1. Okay, and then it should finish like the factoring questions. Something cancels, plug 1 into what's left over. Your answer comes from the square root of 1 plus 1. So if direct substitution is not enough, if factoring is not enough, your brain needs to think maybe it's this conjugate type question. Now, luckily you did practice these quite a bit. I had you do that Khan Academy where you had to stick with it till you could do 4 in a row. So you should feel okay with those. But one type that I think that you do need extra practice on, which is why I'm going to give you some class time here in just a little bit, is like number 3. I did one of these for you in your notes, and I didn't give you any practice the day I introduced it to you. So it's 99% the same thing. The only difference is the algebra in the middle. Conjugates aren't going to make sense here. Factoring's not going to make sense here. You still start off with direct substitution. You still realize it's 0 over 0. You still think about those other things, but at some point you got to realize those other tools just don't help. So what we could do, what you need to recognize is we've got these small fractions within a big fraction. That's called a complex fraction. And there's a handful of times in math where you're going to need to know how to simplify complex fractions. So basically you just multiply every term by these small denominators. The reason why you're multiplying everything by 3 is to make those cancel out. And the reason you're multiplying everything by x plus 3 is to make these cancel out. But if you multiply one thing by x plus 3, everything needs to be multiplied by x plus 3. And make sure you distribute this minus. That's really the only unique thing about this question. The way it finishes, you couldn't tell if it was one of those other question types. We can combine like terms in our denominator, 3 minus 3. Something cancels, times x divided by x. And as the second something cancels, you should be wanting to plug in and hope that it's not 0 over 0 anymore. So if I plug 0 into what's left over, I get 3 times 3 over a negative 1. So it looks like the answer to 3 should be negative 9. As long as you understand why I multiplied everything by 3 and why I multiplied everything by x plus 3, after that it's consistent with the other question types. Okay, so I think I did 4 of those for you, so I will ask you to come back and do the other 6. That'll force you to do complex fractions a couple more times, conjugates a couple more times, maybe factoring once more, maybe direct substitution a couple more times. But to me, with limits, there's really 2 challenging things about limits in my opinion. Limits is there's a lot of little questions, a lot of little things you need to know, the properties and graphs and tables and piecewise functions and what is a limit and what's that got to do with horizontal asymptotes, and there's lots of little things with limits. But when you boil it down, most of those things aren't too much work if you know a little bit about how you're supposed to approach the question, except for these. 0 over 0, these questions can take a few steps and take a few minutes each. These take more practice than a lot of the other stuff. Okay, so now let's look ahead to assignment 10, please.
Oh, we aren't given it yet.
You were not given it yet. It was on the table.
Oh.
It's always on the table when you come in. Unless I forget, which happens sometimes. Okay, the nice thing about, we're going to talk about limit properties. You've actually been using a lot of these already. Most limit properties are very intuitive. There's only one that doesn't necessarily work out the way that you expect. So, again, what we will do here is we'll do the first little part here, the notes, go over a couple of examples, and then we'll jump over to the next worksheet, and then I'll give you time to come back and try these out. Okay, so just like x plus x is 2x, with limits, if you want the limit of something plus something, you can just do the limit of the first term, then do the limit of the second term, and if it says add in between them, add those results together to get your answer. Adding works just the way you would expect it to. And in fact, I'm sure you've probably already accidentally done this in a few other questions. Just do them separately and add the results together. Likewise, if this is a minus, you would do them separately and then subtract. If it's multiply, you do them separately and then multiply. If it's division, you do them separately and then divide. Add, subtract, multiply, and divide You don't really need to memorize anything special. Just know to do them separately and then do the math operation in between. Okay, so when you look at this question for example 1, it looks really complicated here. But again, we can kind of split this up into more digestible parts. So the limit as x approaches 1 of all of this stuff is really the same as the limit as x approaches 1 of this guy plus the limit as x approaches 1 of that guy. We can just split it up into as many terms as it is and work them as smaller questions. Now, using this table up above, if I tried to plug in 1 into this, this would be f of negative 1, which is like this one. You plug in a negative 1 into this, f of negative 1 is 2. The limit as x approaches 1 of g of x over here is 6, and then it says divide that by 2. And then there was a plus sign in the middle. So I'm going to take this answer 2 and add this answer 3 to get my final answer to this question 5. As long as you know that you can do that, you can just work them separately. Yeah.
What do we actually memorize?
Okay. Y'all okay with that? This one's a little funny if that's what you're looking at.
Yeah.
Yeah, because when you plug in 1 into this, it's f of negative 1, which is the same as if you plug in 1 into this, f of negative 1. Yeah, the negative here kind of makes it kind of weird. But the main point is, if you can do this one, you can do this one, you just add the numbers together. Okay, the one that is not intuitive, and the one if I was you, I would put a star by, because again, this is not something, this is one of those limit questions they expect you to know, but you won't get to practice this once a week or anything, and it will end up being on your AP exam. Come March, you're not going to remember how to do this. And that is when you take the limit of a function plugged into another function. So make sure you put good detailed notes here. When you do this, you actually just do the limit of the inside one. You only do the limit once. Then you plug that into the outside one. Limit of the inside, plug it into the outside. Only do the limit once. Okay, so look at this graph over here. What is the limit as x approaches 4 of this graph? Very good. It approaches 1 from the left, 1 from the right. So the whole inside is a 1. Now, what about f of 1? What is this asking us to do?
Find the limit as x approaches 1 of those limits.
Nope, there's no limit here, so no limit for this part.
Just find that value.
Right, it's just talking about a point now, right?
Yeah.
When x is
Negative 1.
when x is 1, y is negative 1. You only do the limit for the inside function. That gets plugged into the outside function and you work it as a point. The answer to this question is negative 1. Now, that's not hard to do, but if you don't practice it sometimes, then you won't be able to do it on our quiz. Okay, next up, so here's another example with the table that's got what looks to be an impossible question down here. But again, since we can do these one thing at a time and then just do arithmetic at the end, it's actually going to be very manageable. So first, and I'll try to color coordinate this for you, the limit as x approaches 5 of h of x is right up here. That's 5. Now, I will admit when I did this worksheet last week, I wasn't paying close enough attention to these parentheses, so I missed it the first time. But parentheses, the limit as x approaches 5 of f of x, it's right up here in the top right, that's the 6, plus 2 times the limit as x approaches 5 of g of x. The limit as x approaches 5 of g of x is negative 1. And then this out here has nothing to do with limits. This is how you talk about points. h of 5 is the point when h If you plug 5 into h, you get a value of 3. So, in the end, being careful about these parentheses, your answer comes from 5 times 4 minus 3, which is 20 minus 3, or 17. So, even the most insane, impossible looking question really just has the same approach. It's a little more tedious, but it's not really any harder to get that answer. I don't know that I've ever seen a question that difficult on the AP exam for this. This is just kind of like worst case. Usually it's just 1 or 2 things. I multiplied because it said multiply, I added when it said to add, I multiplied when it said to multiply, I subtracted when it said to subtract. Just do them separately. Okay, and then the last part of this one, and a big part why I wanted to do this worksheet, because for the rest of it I could have just made a simpler handout, I guess. But we talked about these in the notes quite a bit the other day, but I didn't give you much practice. And then this handout will have a couple sections that forces you to do this. So, reading piecewise functions, I totally understand. I taught Honors Algebra 2 for years, and I felt like we never did enough piecewise functions. I taught pre-calculus for like 10 years, and I still felt like we never did enough piecewise functions. It's not that they're hard, you guys just don't get the opportunity to practice them very much. Okay, but we will today. So, the limit as x approaches -5 from the left. Which one of these two talks about x values to the left of -5?
Top.
Very good. So left means when x, think about on a graph. To the left is when it's a little bit smaller. So if you want to know the limit from the left, it looks like we should plug into the top. And our answer would come from 11 minus -5. And then square root, so 4. Basically, you're just plugging in -5, but you need to think about why I plugged it into the top instead of the bottom. Okay, the bottom one, as x approaches -5 from the right, that's values where x is slightly bigger than -5. And that's being described in this bottom one. So, just plug -5 into here. 5 minus 25 would be...
Would be.
Okay, so that reduces to 1/10. And then part C. Now it's not talking about left or right. So if the limit from the left is 4, the limit from the right is 1/10, what does that tell us about the limit? What? Good, those have to be the same. If it doesn't designate direction, those have to be the same. I know you've heard that 20 times at this point, but it's important to keep emphasizing that. No matter if we're talking about a table, doesn't matter if we're talking about a graph, doesn't matter if we're talking about a piecewise function. For the limit to exist, it has to approach the same number on the left and the right. Okay, and then last one of the notes for this piece, at least I believe. Let me double check. So, piecewise functions can actually come in as many pieces as they feel like. So, this one just happens to have 3 pieces. Doesn't really change our approach any. Yep. So, if I want to know the limit as x approaches -1, now notice this doesn't say left or right, like the last question pushed me in the right direction. But for the limit as x approaches -1 to exist, I need to test the left and the right limit. So if I plug it into the left, I get the square root of 9, which is 3. And if I think about its right limit, I would plug it into the middle one, based on this restriction. And I would get 26 minus 5, which is 21, divided by 7, which is also 3. If it approaches 3 on the left of -1 and 3 on the right of -1, then the answer to this question would be 3. It's got to be the same from the left and from the right. Okay, B, the limit as x approaches e from the right. So which one of these do you think we should plug that into?
The bottom one.
Very good. From the right is when x is bigger than e. This is the inequality that talks about x being bigger than e. Y'all remember the directions of inequalities, right?
Yes.
Okay, how'd you learn that?
Just last year in pre-cal.
You learned it earlier. In
I mean, yeah.
Alligator.
Alligator.
Y'all remember the alligator?
Yeah.
Alligator eats what side? All right, alligator eats the bigger side. Or the bully points at the smaller side, whichever way you learned it. Okay, so you're correct. This from the right should be plugged in here. So we get natural log of e to the third when we plug e into that. Now, in a free response, I know this isn't super important to us right now, but in a free response, this is totally fine. You don't have to do any arithmetic on free responses. But on multiple choice, it's not going to be written like this. They're going to simplify it some. So, do you remember what we can do with this 3?
You can move it to the back, front.
Right. So if it's an exponent on something you're taking the log of, you can bring it down out front. And that's important because the natural log of e is just 1. So as a multiple choice question, it's going to say 3, not natural log of e to the third. And again, this is one of those things about calculus that can be challenging. You learned logarithm properties at some point, so occasionally they throw them at you. You've learned unit circle at some point, so occasionally they throw them at you. Anything you've ever learned can show its head in calculus. Okay, and then finally, the limit as x approaches e of g of x. So I already know the right limit from part B, and then the left limit would need to be plugged into this guy. His limit is 26 minus 5e squared over 7. Is this stuff the same thing as 3?
No.
Definitely not. So this limit doesn't exist. All I cared were they the same. Again, we practiced some of that the other day. I need you to practice more of that. Piecewise functions are also going to show up several times this year. The more comfortable you are reading those, the better some stuff will go. So for a few minutes, go ahead and put that aside. I want to go over one more thing with you. But just to be clear here, this assignment 12, I'm not going to ask you to do any extra on assignment 12 today. When I see you guys again next Tuesday.
Isn't this assignment 11?
Oh, is it 11?
Yes.
Okay, sorry. When I see you guys next Tuesday, I'll give you some time to actually work these questions. But I want to go through the notes today. So just the first page here. Okay, so even when we started talking about IVT last class, there's this idea of continuity. The graph is nice and continuous. There's no sudden breaks in the graph. There's no holes in the graph. There's no vertical asymptotes. It's fairly predictable. I know that if the point's here, it's going to be before it and after it as well. Well, it turns out that continuity is a big thing in calculus. All the stuff we learn in calculus, there's very little of it that doesn't work if it's not continuous. Most everything we learn this year requires for it to be a continuous function. So, that being said, they expect you to know the mathematical 3-part definition of continuity. So, if you are asked, is it continuous when x is some number c, c is just a generic number, there's 3 things you need to be looking for. The order doesn't matter, you just have to know the 3. First off, for this to be continuous, the point there needs to exist. If you're missing a point, you've got a hole. If you've got a hole, it's not continuous. So there better be a point. You don't want your graph jumping all over the place, so a mathematical way to say that is we want the limit as x approaches c to exist, which we know for the limit to exist, that really means we've got to make sure that the limit from the left is the same as the limit from the right. That ensures that the graph's not just magically jumping up or down at point C. And then there's one other thing.
Limit f of x as x approaches c equals fc.
Perfect. Very good. The limit has to be equal to the point. Now this is the one that's a little harder for students to sometimes see that's necessary, so let me draw you a little picture out to the right. I can show you an example where the first 2 things are correct, but the last one's not correct, and you can see it's not continuous. So at x equals c, I can make sure there is a limit here. It's approaching the same thing from the left and from the right. I can make sure that the point exists. I'll put the point down here. But do you see how this hole here makes this kind of jump for a second? It's not really a jump. I don't want to say jump because that's going to confuse us on something else. If the point isn't equal to the limit, that's why you need this one, then you've still got this discontinuity here. You need the point to be equal to the values it approaches. So that's why we need the third one. Okay, so let's go through and answer a few of these questions. So question 1, piecewise function. Is this guy continuous at x equals 1? This would stop fighting with me. Okay, so what you have to do before you say yes, it's continuous or no, it's not continuous, in your head you need to be not trying to rationalize it, not trying to just common sense your way into the answer. You need to think of the three-part definition. Does f of -1 exist? Is there a point when x equals -1?
Yes.
Yeah. When x is -1 equal to -1, you would plug that value in here. So when x is -1, you have the point y is +1. All I care is that it exists. I need to know the points there. Okay, I also need to make sure that the limit exists. So the limit as x approaches, I'll do my scratch work up here. The limit as x approaches -1 from the left would go in up here. 1 plus 2 plus 1 would be 4, versus the limit as it approaches -1 from the right, which would be -1 plus 2, which would be 1. Is this, let me double check this one. I was thinking that it's not. 1, okay, well that's fine. So, do you see that the limit doesn't exist now? Okay, so the nice thing is, when it is not continuous, is it continuous?
No.
No. The nice thing about it being not continuous is that your justification is easy. You just need to state the one of the three part of the rules that is broken. You don't have to state all of them. Just show off the first one that you've figured out does not work. So limit from the left does not equal limit from the right. That's all the justification you would need. Okay, if I do the same thing for part B, again, I'm kind of assuming that it's yes to start off. I'm going to think about, is there a point at f of 2? So I could plug 2 in here. I would get 4. When x is 2, y is 4. So f of 2 certainly exists. There's a point at x equals 2. I know I need to think about the limit. So the limit as x approaches 2 from the left is plugging it in here, which would be 4. The limit as x approaches 2 from the right would be plugged in here, which would be 2 squared, which is 4. So the limit from the left does equal the limit from the right. So that's the second part of the definition. You don't even have to say that it equals 4, by the way. You just need to say that the limit from the left is the same as the limit from the right. Nobody cares what the number is, just that it's happening. Okay, and then the last part is we need to make sure that the point is the same value as the limit. So the limit I just said was 4. The limit as x approaches 2 was 4. What was f of 2? Plug 2 up in here. 2 squared is 4. So those are equal as well. First, second, and third part of the definition are being met. So yes, it is continuous. And I have the full explanation. I have the full justification. So to prove it's continuous, you have to state all three things. To prove it's not continuous, you just need to state one part that's wrong. Okay, we're going to look at the rest of this page and then we'll call it quits here and then go back to the practice. Okay, so identify the types of discontinuity, if any, and where they occur. So 3x plus 1 is continuous, 1/2 x minus 1 is continuous, but they may not be handing off correctly. When this stops being this function at 4 and starts being this function at 4, there's a good chance that there's a break in the graph. There's a good chance that there's a discontinuity. So we are going to plug in 4 into the top. We'll plug in 4 into the bottom. At the top, it looks like it's 13, and at the bottom, it looks like it's 1. So think about that. It's this function till you get to 4, and it has a y value of 13. And then at an instant, it becomes this function, and the y value is 1. Does that make sense how you can't jump from a y value of 13 to a y value of 1? Now, this is going to be far from accurate. But basically what I'm saying is, as x approaches 4, it's way up here to the left at 13, and at an instant, it's down here at 1. This is discontinuous, but you need to know that this is called a jump discontinuity. This one's easy to remember because the whole function's jumping from 13 to 1 at an instant. Can't do that. You can't move that fast at an instant. Jump discontinuity if your graph jumps.
Wait, so that would be the justification too?
We're not justifying on this question.
Oh.
It doesn't say you have to justify. We're just trying to identify the type of discontinuity. Now, there's another type I'd like you to squeeze in here. The other one that's pretty easy to remember is when you have, I just don't know why they didn't put it here, but when you have a vertical asymptote, this is definitely a discontinuity as well. I'll try to find us some practice with this. Does anyone remember what this type of discontinuity was called? We did this in pre-cal briefly.
Asymptote?
Close?
No, 0. I don't know.
What is this going to?
Infinity.
Okay, what is this going to?
Negative infinity.
Okay, that's a hint.
Infinity.
Infinite discontinuity. If it's going to infinity and negative infinity for an x value, it's referred to as infinite discontinuity. Again, people usually remember that one okay too because it matches like with what's happening with the graph. The one that students forget, and the one that you will definitely want to review in March when we get to the AP exam, is one like question 3. So to me, it requires a little more attention here. Okay, but same idea. X squared plus 2x minus 1 is continuous, x minus 1 is continuous, and y equals 5 is continuous. But this function may not be handing off to this function at the right y values, and this function might not be handing off to this at the right y values. So we need to see where is this graph at this time. So we're going to plug a -1 into this to see that the top function at x equals -1 is -2. We're going to see where this function is at this time. So plug a -1 into this, we get a -2. Now wait, doesn't that mean it's continuous? It's approaching -2 on the left and -2 on the right.
Yes. No.
Is there a point at -1?
Yes.
Yeah, when x is -1, y is 5, so there's a point. But what about that third part of the definition? What's the limit equal to? What's the point equal to?
5.
So visually, again, I'm not doing this exactly perfect, but the limit as x approaches -1 is down here at -2, but the point is way up here. That's why it's a discontinuity. This is the type that students usually forget. If you have a hole like this, I wish they would have called it hole discontinuity because you would remember it better, but it's actually called removable discontinuity. That's the one that is not intuitive. So you might want to add some emphasis. Now, even though it does look like the graph is jumping, since it's just for an instant, we don't call that a jump. For it to be a jump discontinuity, your whole function needs to jump up or down, not just a single point. Okay, so a quick review of those. Your whole functions are jumping, call it jump discontinuity. If there's a break in the graph because they're going to infinity and negative infinity, call it infinite discontinuity. And if it's because there's a whole discontinuity isn't a thing, removable discontinuity is its name. So, yeah.
Is this still removable discontinuity if the point doesn't exist?
Yes. Whether the point is there, great question. Or if the point is not there, it is still called removable discontinuity. So just focus on the whole part, not the whether there's a point. But great question. Okay, and then last one I want to expose you to today. Doing kind of the same work, but it's one of these where this is how they like to ask it on the AP exam, and the first time you see it, it looks pretty confusing, and sometimes you don't know how to start. Okay, so we've got this function, h of x, and we're supposed to figure out what value of k makes this continuous. So we certainly don't want to just plug in numbers and see. For this to be continuous, I need to make sure, well, first off, assuming k is just a constant, and it is, k is just some number we don't know, but 4x plus a number is always continuous. 2 minus x squared is always continuous. So the only place there might be discontinuity is when it switches from being the top function to the bottom function at x equals negative 2. So let's plug in negative 2 here. So that function's at negative 2 when it stops being that function. I'm going to plug in negative 2 here and get negative 8 plus k. And for it to be continuous, how do these things need to compare?
They need to be the same.
They need to be the same, because if they're not the same, it's like this question. 1 to 13, you've got a big jump. If this one's approaching negative 2, I need this one to approach negative 2. So you really just set these two things equal to each other, and then you're left with a one-step equation. K needs to be 6. That ensures they have the same y value at negative 2, which is where it stops being the top function and starts being the bottom function. Okay, so that's all we need to talk about continuity for today. Again, I just want your brain to start thinking of that, to hear the 3-part definition. That way we can kind of hit the ground running with that on Tuesday next week. But with the second half of class where I really want you to spend your time, I want you to finish assignment 9 first. This is review from a few classes ago, and I did 4 of the 10 questions for you, so you should only have 6 more of those. Answers are on the bottom. If you're not getting the answer on the bottom, you need to start working with your person next to you and or call me over so I can help you. We're not going to spend much, if any, more time on this topic after that. And the only other one you need to do between now and next Tuesday is assignment 10. So after you finish this assignment 9, move on to assignment 10 and get as much done as you can in class to minimize how much, if any, homework you have.
About the Khan Academy, I totally forgot I had my name set as my...
Did you email me about it?
Yeah.
Yeah, I just haven't gotten to it this morning. I'll fix
Awesome.
it.
Okay, thank you so much.
Yeah, it wasn't a
Sorry,
problem.
that was totally my fault.
Oh no, it's fine. I understand that.
Thank you.
I knew somebody was gonna be upset they had a 0 and they would come tell me eventually, so I'm more than happy to fix it. So you've got the answers to assignment 9 on the bottom, and the answers to assignment 10 are on the website. So when you get to that, please make sure you're using that. And give me a couple minutes here. I'm going to grade these homeworks first. Get them back to you, and then I'll offer to help you out. But you guys are welcome to work together in the meantime. No, I got it. Harper, right?
Yeah.
Yeah, yours was on there.
Okay.
I found two others that don't have names on them, but. Huh? Yeah, if the pass is there and it's not the first or last 10 minutes, you know. 2 no's in here, so if I ever mix up these papers, just let me know. Okay, before I offer to help out with a couple of questions, there was 2 names, or 2 papers that got turned in today with no names. So if you gave me your hard copy this morning and you did not just get your paper back, one of these 2 is probably yours. You need to come put your name on it so I can get you the points. Okay, I got it in there now. So yeah, I'm keeping it under.
Did you get mine?
Yep. Okay, so now I've got all those graded and passed back to you. Let's see, we still got about 22 minutes, so certainly plenty more time to chip away at the homework. But first, let me offer, is there any of these questions on assignment 9 that you will need me to go over with you? Just trying to offer some help. Yeah, Ryan, which one?
We do
Number 8? Sure. Okay, let's see. So question 8 is supposed to come out to 1/10. We got the answer at the bottom, so I'm going to put that down here just to make sure I check my work that way. Okay, so my normal thought process is do direct substitution. Hope I don't get 0 over 0 because I would be finished. If I do get 0 over 0, I'm going to try factoring first. Unfortunately, nothing factors. Then I'm going to have to start digging a little bit deeper. Because this one has a square root in it, this is probably, and I don't really know for sure until I try it, but this is probably a conjugate question. So I'm going to multiply the top and the bottom by the conjugate of the numerator. Square root of x plus 12 minus 5 becomes the square root of x plus 12 plus 5. You only change the middle sign. Don't change more than that. Okay, and then when we do this, the denominator is going to be easy. I've got x minus 13 times this stuff. There's no benefit in foiling that out, so I'm not going to. But when I multiply the numerators to get my numerator, because I'm multiplying something by its conjugate, this is where it simplifies nicely. And that's why this whole conjugate idea is helpful sometimes. So first part of FOIL, square root of x plus 12 times square root of x plus 12 would be x plus 12. You can write down the next 2 steps or not because it's always consistent. The outer part of FOIL and the inner part of FOIL are always going to cancel when you multiply something by its conjugate. So the next part would be the negative 5 times 5, the last part of FOIL, which would be minus 25. And then combine your like terms. Instead of saying plus 12 minus 25, make it say minus 13. Once you get to this point, you should be feeling pretty good because now it just finishes the same as all the other questions finish. Something cancels, plug into what's left behind. Direct substitution into what's left behind. So we end up with 1 over 5 plus 5, which is 1/10. Okay, was there something more specific in there? Anything I went over too quickly? Okay. Is anybody else going to ask about 8? Have something more detailed about it while it's still up? Okay. Is there another one from assignment 9 that y'all are having more trouble with than others? What about assignment 10 then? Yeah, Tyler.
On question 9, part H, it says, what is W when it's 2 pi? But none of them have a equal to 2 pi. It's only greater than or less than.
I know exactly what question you're talking about. This one?
Yeah.
9H. Somebody yesterday asked that question too. Okay, so 9 gives us a 3-piece piecewise function, and part H is kind of weird. So, is this a limit question? This is just referring to a point. It's saying when x is 2 pi, what is y? That's what it's asking you here, right? So, does this top part of the function exist when theta is 2 pi? Does the middle function exist when theta is 2 pi? Almost. If this had an equal to sign, it would, right? You would plug 2 pi into cosine. Does the bottom, does theta equal 2 pi there? Okay, so then there's never a time on this function when x is 2 pi, so there's no point or does not exist, right? Does not exist. No part of that piecewise function ever exists when theta is exactly 2 pi. Before it and after it's fine, but if you need to know exactly at that time, it doesn't exist. Okay. Others from assignment 10 that you have ready to go? Okay, I'll get out of your way and I'll offer one more time before we run out of class time today. So if you get hard stuff, just mark it temporarily.
So, did you turn in number 7 at the beginning of class today? I came in late.
We did.
Okay.
So you need to start turning it in Google Classroom.
Oh, got it. Okay.
That way, if you're late, you're not going to lose points.
Okay.
I didn't give you late height this time, but again, in the future, I just have to make sure that you're not going to do it in class. So that's why I have this. So, Google Classroom, always going to be an option if you want to turn it early. Otherwise, you got to. It's also fine, like if you came in a couple minutes late, if you just give it to me right away, or just come put it in the basket right away, it's fine also. The problem is the agenda may not be up on the board, so. Okay, so look right here. If you think of this like direct substitution, if you plug in a 3 here, this is g of -3, right? Well, over here, this one, if you think of direct substitution, you plug in a -3, g of -3 is 5. You can't just take the opposite of this answer because it's the opposite of this value. You're making an assumption that it's like got symmetry to the graph. then plugging in 3 here gives you a -3, which is the same as that. These are not my solutions, but they should be fun because I think this is one of Answer looks good to me. Does the part B okay?
Yeah.
It might just have a typo there. Yeah, you did the limit of the inside part, and on the outside part to the point. Yeah, that's what you're supposed to do. Is the Starbucks group up here? Mercedes. You good for Starbucks?
Yeah.
So, for number 4, the answer sheet says that this doesn't exist,
Yeah.
but I
It
don't.
should be 1. You're right.
Okay.
Yeah.
Okay.
Sorry, I know I meant to talk about this the first several classes, and I think I even had it on our agenda the first few days and never really got to it. But so you guys know, we do have calculus textbooks, and you are more than welcome to check out a textbook if you want one at home, or I know some of your parents prefer you to have one at home. Honestly, we will use the textbook about 5 to 10 times this year, and I will just make copies for you so that you don't have to carry a textbook around. But if you want a textbook checked out to you, that is not an issue. It takes me 30 seconds. So if you want to check out a textbook, I can do that for you today. Or if you decide in a month from now you want a textbook, I can check that out to you. So just so you know that that's an option. Also, in case I didn't say it, I do have classroom calculators up here, so I have a set of 10. So if you forget your calculator, your batteries are dead, anything like that, you're welcome to just borrow mine. Just always try to get it before class starts, please, and of course put it back at the end. Don't leave it on your desk. But since this is an AP level math class, we also have calculators that you can check out for the entire year. So if you don't own your own class calculator, and you don't want to spend the money on it right now, you'll probably have to at some point in college anyway. But I can check you out a calculator just like a textbook. You can take it home, you can leave it at home, it's there for your homework. But like a textbook, if you lose it or damage it, it's like, I want to say like 150 or something. These are a little bit more pricey than the Walmart ones, the yellow school ones. So pretty expensive if you lose it, but you're also welcome to check out a calculator and then just return it at the end of the year. So if that matches you, if you would like to check out a calculator, same thing. I just need to know. I can do that for you today, or if in a couple weeks you decide you want to do that, I can do it for you in a couple weeks. So that's an option. But you do need to have a graphing calculator. I mean, you can really use Desmos too, but this is the type of calculator you're probably going to have in front of you during the AP test, so you might practice with that anyway. Okay, let me, we got about 6 minutes here, so let's wrap up. Let me remind you, first off, what's has to be done by next class. So again, tomorrow is an A day. You guys know there's no school on Monday, but next Tuesday will still be a B day, so I won't see you till next Tuesday. You need to have assignment 9 and 10 finished, and I guess if you didn't do 8 on time, you accidentally got a little bit more time there. 11's the one you don't have to do anything else for. You should probably write that down on the top of your pages or in your agenda or whatever your system is. But if you ever forget, just go to our class website. This agenda is on the top right, and you can just look at the little homework box in the bottom left to get a reminder of that. So that's number 1. Number 2, this is one of my favorite daily memes of the year. I always use this one every year. So can anybody explain to us the math behind it? Okay, it is an inverse function. So the top is a function where the cat's eating the fish. So the inverse function, those two things should switch. So now it's the fish eating the cat. So I like that one. Okay, and then my puzzle for you for today might be a little bit different. I don't know which one we're at. I know we did the clock. We did the chessboard. We did the chessboard. Did we do the socks?
No.
Okay. This might be the easiest one yet, but also somebody in one of my other classes complained that this isn't really a puzzle, it's just math, but that's okay. Still good for you to see if you can do it. I posted the answer and explanation to Google Classroom if you're interested.
Are we grabbing the socks at the same time or one at a time?
That's a good question. That would make a difference, wouldn't it? Well,
That was Keon's question up on the couch to him.
that was a very good question. Yeah.
Can I grab them at the same time?
11 over what? Nope.
So half?
It's not half, but it is close to half.
Can I grab that?
Okay, so when you reach in, what are the odds that you grab a sock?
50-50.
11%.
Oh. Depends which sock.
You reach in the box and you grab a sock. What's the odd you grab the first sock?
100%.
100%. You don't care what the color is the first time, right? Okay, once you pick the first one and now it's determined, and you're doing your second pick, how many of that color are left behind? Out of how many could you grab? So 11 over 23 would be your chance. And 11 over 23 is about it's about 48%. It sure seems like it happens less often than that, though.